Yeah, do you have his phone number? Maybe you should text him.
Yeah. Well, he doesn't get text, so I'll give him a call. All right, we are live. I see the stream is showing up out there in YouTube land. Hello, everybody. We've got 4 watching. I'll give him a call. It's me and Soundly on here, and we're just waiting for George to arrive. I'll try calling him. He told me his VoIP was acting up or something.
Yes, while I'm thinking about it, let me get that time lapse.
Yeah, dig up that time lapse. Yes, Soundly and I. What did I say?
Oh yeah, I need to.
I misspoke.
I
And
need to get the chat up to. Oh yeah. Let's see here we go. Pop out chat.
looks like some of the folks have been in touch with Bilu. So yeah, it's out now. You know, Bilu can't keep the secret anymore. We learned so much from Bilu.
Yeah, so for everybody that's joining, we kind of thought George was going to be here. We're wondering maybe there's miscommunication or something. We're trying to get George on the phone or chat or something.
I called him. It went right to voicemail. I guess he's 2 hours back, right? So it's like 6. A lot of times he's just coming in off the ice around.
No, he's Central Time.
Oh, he's Central. Okay, 1 hour. We'll try him again. But in the meantime, if you want to share your screen.
Sure. Yeah, let me do this first. Actually, I could. These time lapses are so short that I could show like the different steps I went through to put them together. But just for everybody that's listening, we set up a P900 on 2 days, and just did a time lapse, and I just manned the battery, made sure the battery, was made sure we didn't have any gaps. Basically, the first day, I guess I kind of scratched that down as a trial run because it didn't really come out the best. I had some gaps because I didn't tend to the battery well enough, and also had some. For some reason, I decided to realign things. I don't know what happened there. But the second day, I was able to just leave the P900 alone for the most part. There is some alignment issues, but I think that's because the P900 just droops or something. I'm not exactly sure why the alignment got off. But what I'll do is I'll share all 3 versions. I'll share the unstabilized time-lapse version, stabilized time-lapse, and then the stabilized and crop time-lapse. And I'll also release these after this hangout publicly so that everybody else can take a look at it. It's nothing fancy. It's just time-lapse, no music or anything. But, I think you guys will probably appreciate it, so let's just go ahead and do that. All right, sharing my screen. Jesse, I think you have to present me, though.
All right, let me do that.
And, yeah, so this is the unstabilized version. This is just me taking all the, I can actually slow the speed down a little bit here. Let's see, 25% speed. and maximize this guy. And let's just, so here's the time lapse. So for everybody that's watching, what George did, whenever it gets to a really, there's a couple really crisp frames in here. When it gets there, I'll pause it. But what George did, just to give everybody an overview, was he calculated the height above, above our baseline, which was the water level, for a tangent line to be lined up with his observation point. And then he went out and he installed these markers out on the tangent line, essentially. And so here's a pretty good frame. These markers right here, the top markers, these four, are all on the same tangent line. And what he's been trying to do is just observe the effects of refraction. These are pretty much all on the same tangent line, which I think Jesse will speak to as far as his measurements go, because he actually used GPS receivers to spot those exactly where they were. And I think he said they're all within 6 inches. Is that right?
Yeah. Can you hear me? I just was talking to George on the phone. He just got in off the ice. He's got wet feet, and he needs to take care of himself a little bit before he comes online. But I wanted to correct just one thing. These high targets, I guess the higher targets weren't set by calculation. They were literally set by visual alignment. So in other words, George has been looking out over this ice for days on end, and he's seen it in every kind of condition of lots of refraction, and he pays attention to the wind. If the wind's blowing across, I think from left to right off the ice, it clears out and settles down the air so well that on those opportunities, he aligned these targets to his level.
Okay.
Horizontal tangent line. So he really did it by visual.
Okay.
And then recorded the measurements of, like what they actually were. So kind of reverse of calculating where it should be, but he set them by visual alignment with the crosshairs and then measured what they were. And then, like you were saying, the lower targets are all set at the same height above the water.
Yeah.
Now,
so these lower targets right here are all at 73 inches, right?
Correct. And then as far as the surveying that I did was simply to get a very, very good location of each target and the shot on the ice surface at that point. Hopefully tonight or soon, I'll be getting from George his measurements from the water to the ice surface, and then of course up to the high targets. And then once I have that, I'll be able to calculate the actual literal positions of each target.
Okay.
So that'll happen at some point here. But we have really good elevations at each target, and actually latitude and longitude. The 6 mile target way out there, that's so high above the ice that, I mean, we literally had to hold the GPS receiver up at the target, and George did that. He climbed the tree again.
Yeah.
Climbed up there. We had the GPS receiver taped onto a like 18-foot long 2x4, and he was up there holding it. And I took probably about 7 or 8 good locations on that 6 mile target. So we have good locations on everything. But anyway, go ahead and proceed with what you were showing.
Yeah. I just stopped sharing for a second because
okay.
I have some pictures that on my personal photo album that I was going to share. I just want to pull those up real quick. Let me see if I can find them real fast. Oh yeah, here we go. I'm trying to find a good one, and Let me see if I can do it through sound. Let's see here.
While you're doing that, I will actually look for some pictures I took as well.
Here we go.
Through my phone.
This is a pretty good one, I think, in my opinion. This gives you an idea of the 6 mile target. That's me standing right there. Oh, I'm not sharing my screen. Hold on. Sorry. Let me do that.
You should still be. I didn't change anything on my end.
No, I stopped screen sharing for a second.
Okay,
So I could pull up
there we
this.
go. Yeah, nice. There we go.
So yeah, here's an idea. This is the furthest target that he has, and he scaled up each of the targets. Logan, hey, do me a favor and take the dogs out. And he scaled up each of the targets so that they would look about the same size. This one wasn't quite the same. It was a little bit too small for its distance, but still, it's really big. And George actually climbed up in that tree and hung that himself, which is impressive.
Yes.
And this is me. I'm about 6'3", I guess, and I have some boots on, so maybe 6'4" right there. This is 13. Where I'm standing is about 13 feet above the water, and that's another, I don't know, 20 feet up there, 30 feet. It's way up there. So going back to the video here, that is this target right here. If you can see my mouse. So that gives you an idea of just how high that thing really is off in the distance. And George lined all these up. This one, this one, this one, this one. These are all the same height. And like Jesse said, I guess he visually lined it up. I thought he calculated the height, but I must be mistaken there. So let me just let this unstabilized time lapse. So anyway, I just want to point out that you can see these lower targets starting to curve right here. These are all the same height above the ice, and these higher targets are staying straight, staying on the same line anyway, which is a really good way to demonstrate that it's not atmospheric effects that are causing it to curve, because if it was, then these also would be curving. But there are atmospheric effects, refraction, for example. Well, that's the primary one that we've been discussing. And you can, in this time lapse, see the effects of refraction because the alignment of these higher signs changes throughout the day. So like I said, this is the unstabilized version. The P900, I actually asked George if he could build a mount for me on the last day. I wish I would have thought about that before, but the P900, just even with on a tripod, nobody standing around it on its own, even just a little gust of wind, you can see how much it moves around when it's at full zoom. You can see that far target getting higher and higher and higher right now. You can actually see it happening in this time lapse. Another thing that's really not ideal about the P900 is the focus just doesn't do well with the autofocus, and you can tell that in the time lapse. It just struggles to get some crisp shots. And I put it in manual focus, and unfortunately, whatever was going on in the atmosphere, that manual focus needed to change. So second day I put it in autofocus and got pretty much the same results. But look how high that far sign is there as the evening's rolling in.
Well, that was very noticeable on the 2 days we were there. We would watch that thing, and it would be way up high. So who is it that keeps saying everything drops in the distance or something? What is that?
Yeah.
Something. Maybe somebody in the chat has heard that things drop in the distance.
Exactly.
Sadly, there must be something wrong with your photography.
Look how high that is. Look how high it is now. Look how high. Look at that.
It's obviously faulty photography. Things don't rise up; they drop.
So let's just go back to these last few frames here. So this is the evening rolling in. It's getting dark, obviously. Look how high this sign is.
Yes.
And one of the things you'll notice, though, if you really pay attention to these time lapses, and it'd be good to go ahead and move on to the stabilized version. It kind of gives you a better idea that you'll see noticeable, like either towering or stooping, or maybe both, depending on the distance. So there's definitely refraction at play there. So here's the stabilized version. Let's look at this.
Describe what it is, this stabilizing process. What is it? What actually happens here? If you can, oh, look at that.
So I use Blender. I've been using Blender lately for the stabilization. And essentially what you do with Blender is you pick out some point. In particular, I picked out this sign right here. And you just basically tracked the center of this sign right here. And what Blender does is it re-renders the video by adjusting each frame so that that track point is in the same exact location.
Okay.
And so that's why you see this black area down here, because the frame is actually from here way up, a little higher.
Mm-hmm.
So that's what happens,
Oh, yeah, I see what it's doing. It's localizing on the point that you selected.
Right.
That's
exactly.
cool. Yeah, very cool.
But the cool thing about, doing a time lapse like this, you could even do this with a cell phone, really. I mean, almost every camera is higher resolution than 4K, right? So you can take I could actually even get higher resolution still if I wanted to go back and do this again. But you can take those high resolution images and turn them into 4K. And that's what I did with these. I turned them into 4K videos, and then this cropped version, which just crops down on the signs of the targets themselves. It gives you, even a better feel, because you get to see more, pixels in the screen, especially with a share like this. So this cropped version, I was actually pretty happy with the way this turned out. I mean, that frame right there. Let's go back to that. That frame right there is just nice.
Yeah, it is.
I wish every frame was like that, but this gives you a really good idea. These are the 73. Is it 73 inches, George? 73 inches for the lower signs, George? Can't remember.
George is in, but I don't know if his volume's up. Turn your volume on, George.
Yeah. The lower targets are at 73 inches above the surface of the water.
Yeah. So these are the 73-inch targets. You can see them, as they start to curve over the horizon here. And these are the higher targets that are all on the same sight line, on the tangent line. And so, again, I could slow this down because it's actually really fast. So let me slow it down. And I think the coolest part of this whole time lapse is the evening. When the evening starts to roll in and you see that far 6 mile sign just start
Rising up.
Rising, just lifting higher and higher and higher.
Or maybe it's us that are dropping down.
But you can actually see there's some stooping going on in the foreground by if you just visually look at this, the top of this closest marker, and this, and you just look at this gap right here, you can see that gap changing. It fluctuates throughout the time lapse. And that's just you're seeing the effects of refraction right there. I mean, plain as day. And it's unfortunate that the P900 the auto zoom just couldn't get those sharp images, especially when it started getting closer to the evening. Struggled a lot.
Yeah, without as much light, it's going to struggle.
But you can, I mean, look at that far sign right now, how high it is.
Yeah.
And then by the end of it, like the last frame, it's way up there.
And this is the day that you had it on autofocus, or you took it off of autofocus?
Yeah, I had it on autofocus. Look how high that is.
Yeah, it is.
But yeah, unfortunately, the P900 is just really finicky. I mean, even when I had it in manual focus, I would get blurry shots, and I think that was because just the atmospheric conditions change and the focus changed. I don't know really how to explain that optically, as far as whenever it's in manual focus and you have it focused in really sharp, and
Mm-hmm.
and then it still goes blurry. It has to do with the atmosphere. I'm not sure exactly how to explain that.
George, do you need a little bit of time to get together anything you'll want to show tonight? Because if you do, I want to show a video of you climbing the tree.
Yeah, you can go ahead and take care of things. I'm just offloading stuff off my camera right now.
Okay.
I do have some pretty cool videos to show just of the area.
Oh, do that. Yeah. Yeah. You. By the way, the first time you sent the drone out following us in the snowmobile, did
That's the first video I'm going to show you right here.
Okay, cool.
So let me maximize this video. Full screen. Yeah, this gives everybody some context on, when you look through the P900 or when you look through any telezoom, it's really hard to get context because because of depth compression. All those signs look like they're really close, but 6 miles is a long ways.
Yeah, it is.
It really is a long way, and like my footage, people have a hard time understanding what they're looking at because they're just not used to seeing it. But this drone footage kind of gives you a very good idea, some good context on just how far these markers are from each other, and also how cold it was.
Let's see, how far away were you able to get that drone out there before you lost link with it?
I got all the way to the sign.
I mean, to the first one or the second one?
Yeah, here. Let me just speed up and get to the. So there's the first.
Yeah.
The closest sign right there.
That's the 0.7.
That's 0.7. And then this is the 1 mile right here.
Yeah, 1.36 miles.
1.36 miles. So I was able to, get a little bit of good footage before I wrecked it.
Well, what was interesting was we were out there and you called over the radio that you lost touch with it. And George and I just looked at it and there it was, just hovering. And we were like helpless to do anything. It's like 30 feet in the air. Like, what do we do? But then,
I was amazed at how it just sat there. It was like dipping its head into the wind, fighting the wind. It was kind of cool watching it sit there and trying to negotiate and compensate for the wind.
You can see it right now. You can see the tilt on the horizon there.
Oh yeah,
it's leaning into the wind right there.
Yeah.
So I actually put it in the Mavic has this circle mode where you circle around, and that's what I was hoping, that I'd just be able to circle around you guys. And the entire time it was fighting the wind.
Yeah.
It was complaining to me the entire time, high wind, and then it was saying battery efficiency works best in warmer weather.
Yeah, we're not getting that here, boy. You know? Yeah.
But I did end up getting a little bit closer to you guys here in the end. Let's see. Is it this video? It might be the next video. I think this is actually when I lost contact with it. So let me go to the next video so you
Yeah,
can
it was
see.
to the east of us when you lost the contact, and it was like Jesse said, about 30 feet above. And I was getting onto the snowmobile. I was going to follow it, and then all of a sudden it went way up in the air, and I'm going, oh shit. I can't see it.
I guess, is that when you regain connection and you just told it to come home and it just fought its way back to you? Is that what happened? And it ended up in a tree, right?
Yeah, I'll show you that video too.
Yeah,
Might as
okay.
well.
All right. Yeah.
But it tried to come home, but it couldn't come home. If I'd have to do it all over again, 2020 hindsight, I'd have just sat it down right there next to you guys.
Right. And we could have just scooped it up. Yep.
Yeah, exactly. But some pretty cool context shots, at least, you know.
Oh, absolutely. Look at that.
That drone is pretty cool.
Yeah, I agree. Yeah, right there, it's like it's drifting away.
The wind is
because of the wind.
Started watching it. I was just gonna hop on a snowmobile and follow it, and like I said, it went way up in the air, and then going, oh.
Let's see. I think this is the one where I bring it home. Yeah, I tried to bring it home anyway. Right there is like, this is go home mode, and home is over here.
Oh boy.
And it's just, the wind's just taking it. So I was like, oh, I'll bring it down to a lower level. So I brought it down to a lower level to try and avoid the wind. And so now I'm manually driving it, but I'm trying to get behind the trees so I can actually get some momentum going. And then all of a sudden the battery went into low power mode. And when the battery went into low power mode, it tried to go home again.
Oh boy.
And then it took control. It took control and just drove right to that tree. See, he's still trying to go home. Oh, there it is. Yeah, that was the end of it. That was the end of my Mavic experience for that trip.
Well, lucky it didn't find an eagle's nest and an eagle pick it up.
Mm. And here's the rest of the pictures I took with that drone. Thank God the battery lasted long enough for me to track it down with the GPS.
Oh, is that what you were able to do? Just walk your way to it?
Now, the other interesting footage was from the first when George took me out to the 20-mile shot.
Now, this is the other drone?
Yeah, this is the other drone. Wait, yeah, that's the first. You know what? I might not have copied over the. When did we do that? On the 2nd, George?
I think you must have done that on Monday.
In the morning.
You got to take this call real quick.
Yeah, that was on the 2nd. Sure.
Okay, yeah, I'm going to have to get the 2nd footage and copy it over to the computer.
Hey, George.
Yeah.
How are the sighting conditions this week? Earlier in the week, I saw you posting that you had snow. You had
yeah, we had a couple
foggy.
days of snow, and I had about 3 days where my visibility was less than a mile out there. I mean, one day it was snowing real hard, and then the other days there was just ice crystals in the air, which was enough to limit the visibility. And then it got real cold that one day too. I went out to I made 2 trips out to the 6-mile target this week. the first time I went out was dreadfully cold. And things are changing now. The last 2 days, the afternoons have been getting upwards of 40 degrees, and I'm finding that I have a window of opportunity. It's about 11 in the morning to about 1:30 in the afternoon. Seems to be that the during that window, the air is fairly stable. The air temperature and the ice temperature are about the same, and then after that, it just the amount of shimmer and turbulence, thermals over the ice is just horrible, and I can't do anything. So it's looking like what I'm going to be doing now for the next few days is just kind of going out about 10 in the morning, take a look, and just keep monitoring. I have to monitor, like, be really on top of it in order to catch the low refractive air.
Okay. Have you been able to capture any?
Oh yeah, I got some really good stuff yesterday.
Excellent.
I mean, it was probably the most stable air I've ever seen. I mean, I've seen some stable air just before you came, and then we did have some stable air while you and Sonley were here for a while. But boy, what I had yesterday was just absolutely incredible. In the morning, and then it was around 12:30 in the afternoon. I had about an hour's worth of really great viewing, and I happened to get some good footage of the first part of the Bedford level type test, where I was able to get all the lower targets on a tangent line, at 73 inches.
Okay.
Oh, this is great. I want to see this.
Yeah. Will you be able to show some of those this evening?
Well, I'm trying to grab it right now.
Oh, okay.
I want to see this.
Yeah, absolutely.
Oh, okay. Yeah, so this is the 20-mile shot. So right here, you're just seeing horizon of ice. And what you'll see if you look really closely right here, I could actually take this into iMovie and actually crop down on that to see it even better. But you just watch right here where you see this ice horizon.
Okay.
And you'll see as things come into view as they get higher. Which those are the hills that are 20 miles away. That's the 20-mile corridor that George was talking about.
Okay.
And, yeah. So I went all the way down to the ice right here. Now I'm coming back up. And you'll start seeing as those hills start to come into view.
Oh, I need one of these.
And on this day, the weather was playing a lot nicer where we were, like in this location.
Mm-hmm.
So it was a lot more stable footage, a lot more stable footage than I'm used to with this drone. And I was able to get pretty high, And the higher you get, the more land comes into view.
I wonder why that does that.
Yeah.
Oh, that's really near on the right side. You see Lake Captogama coming into view.
Right here, George.
Over there, yeah. Over to the right.
Never mind. Yeah, that patch of water there that's just in the center of the screen there, that's over at Lake Captogama. Another big lake that flows into Rainy Lake. It's about 12 feet higher than Rainy Lake. There's a waterfall about 40 miles from here called Kettle Falls that Captogama feeds into Namakan Lake and then pours into Rainy Lake at Kettle Falls. Oh, I love this. This is great.
I think Soundly had to take a phone call. He's on mute right now, but this is
Yeah,
really cool.
I'm taking a phone call, guys. I'm sorry.
Oh, yeah, that's okay.
But you can still see going up into Seine Bay on the right-hand side there, that 20-mile corridor. You can kind of see there's that little opening there in the water. Well, that wasn't too bad. When I was looking through my camera from the deck on this one house, I thought maybe Sully wasn't going to get very good shot because it sure looked hazy to me, but looked like once you get up in the air, the haze disappeared.
I guess this was on Monday. Must have been. I was already
Yeah,
gone.
this was Monday morning. Mhm.
Yeah. Okay. Yeah. Okay. So after you guys dropped me off at the airport, then you probably came over here.
I took him over to this, and then when we got home, we loaded up the snowmobile, and I took him to the 6-mile target.
Okay. Yeah.
I
Earlier.
was a little concerned about doing that because if we ever had a breakdown or something, Sully would have missed his flight.
Here he is coming back down. You could tell he's trying to stay centered on that corridor.
Right.
This is the drone that gives him a little issue with that, but he's keeping it in the center there pretty good. That was great. Hey, while he's on the phone, I'm going to try to present and show this video of you up in the tree.
Okay. Well, I'll go and try to grab my files for you.
Okay.
Hey, go on. Good boy. Come on. Move. 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 Move.
That's a quick one. I don't know if everybody could hear that or not. Here's the longer one. Where's the other one?
All right, I'm back. I might have to run out again. I'm trying to manage kids and dinner and all that. Jesse, I think you need to present if you're trying to.
Oh, you weren't seeing that?
Uh,
I thought I did.
yeah, I don't see. All I see is your avatar right now.
All right, I always do that. All right, let's try it again. How about now?
Yep.
You do see it?
Mm-hmm.
Okay. I'm going to put my speaker into my earpiece so you could hear this. Somebody's got a phone ringing. Here we go.
Hey.
The other thing I'd like to show is the snowmobile ride back. That's probably the longest one. It's
So I did end up getting another video while we were out there. That's probably the best one, especially if you want to do like an elevator type thing. It's only 1 minute long, but it's pretty much stable the entire flight up and down.
You want to? Are you queued up to show that now, or?
I don't have to show it. It's on my screen right now, but
Looking for the. Oh, this would be a good one to show.
Yeah, just so that people know, that's the laser shooting the 6 mile corner reflector.
Sally, are you back online, or are you on a call?
yeah, I'm here.
Hey,
I was actually showing my
hey
favorite.
Jesse.
Yeah.
Rumpus just Skyped me. He'd like to join in.
Let's see. I don't know if I.
I am here, Jesse. I was just showing my favorite clip from the drone footage, actually, right here.
Let me see how I can add. See, I don't want to.
I could get back to Google Hangouts and pass them the link here.
Okay.
Let's see.
Share this real quick, Jesse.
Okay, I'll give it back to you.
Is it on me? I don't think it's presenting.
It should be now.
Yeah, this is my favorite clip of the drone footage. Khan showing love to his master.
Ah, Rumpus is in.
Oh,
Hello.
great to see all this stuff. Great to see all this stuff going on, and best, of course, seeing George climb a tree. Love it.
Yeah. And I do want to get a video in showing us coming back across the ice, and then Khan coming out to greet George. You got to see that.
Oh, his Khan's great, isn't he? Yeah,
Yeah, he's great dog.
When I was doing this, trying to collect this video for George last year, which I still haven't done, of course. I was trying to get Khan doing sort of video shots, me sort of trying to make him look as though he's directing things and looking left and right as George is dashing backwards and forwards across the camera and all sorts of jokey things like that. Because he's got such a character, isn't he? I mean, obviously you've met him now. Is he as silly and sort of engaging as he is on film?
I would. Khan is the way I described it to George is that in Khan's world, the only person that exists is George. The rest of us are like accessories.
Right, but presumably because you were friendly with George, presumably you got permission to do everything and he didn't sort of take objection.
Yeah. No, but he's very friendly. He'll come over and he'll glance at you and he'll let you pet him, but he's waiting for George.
Right, yeah.
I think I just saw a message from Soundly that he had to run and pick up the kids. So I think he's out of the hangout for now anyway.
Oh, right, okay.
Well, let me dig up something else. And we're just waiting for George is offloading some photography that he's going to be able to show us. I guess that he took today.
Right. So yes, I heard George saying he's got some great observations from yesterday or something.
He did. He said he's got some good stuff. It'll be nice to see.
Did you manage to get some good stuff when you were there with him?
Yeah, I do. I have.
I just saw your drone foot. Soundless drone footage. That's not yours, isn't it?
Right, that's Soundly's drone footage.
Yeah.
I have some pictures through the level telescope,
Right.
And what I was going to just show now is just some video of us working, but really looking forward to seeing George's photography from today.
Right. Has he not done any previous stuff? Has he not had a chance to get any decent shots prior to this then?
Not the way he's done it today. In other words, he's been looking for an opportunity to get the level set up 73 inches above the water.
Oh, for the sort of Bedford levels thing, right?
Correct. So he's been working on that.
Right, I see.
And he's been describing that the weather's been bad. There was snow, foggy conditions, but he said he got some good stuff yesterday or today. But
right. So has George got some good stuff? It must be hasn't been keeping me up to date over the last week or so. Been too busy, obviously. So has he got some good stuff through the sighting the targets then through the auto level, etc.
Correct. That's what we'll be seeing when he comes back on.
Oh well, no, I was thinking of the targets, the ones that are aligned, that should be in a line. Not the Bedford levels one, but the other ones. The ones on the ones. For instance, the one in the tree. Has he got some nice footage of those?
I think so, and I do as well. It's just simply been that since being out there, what was it now? We're at Thursday. Like this Sunday would be 2 weeks ago.
Right.
Both Soundly and I, as soon as we got back, it was like right back to work. And this is our first time that the three of us are even. Well, Soundly's off the hangout for right now, but this is the first time we've even converged to get together. So,
all right. What's this picture on screen? Is that a big camera you got there or something, or big telescope or something?
Yeah, that is. Let me back that up. That is Soundly's Celestron, I think it is.
Oh my God!
And this is a Sony. I don't know what the model is, but he had this out here, and he had the P900 over here to the left. This is George's TopCon
auto level, right?
That he mounted the laser on top, and that is the 6 mile.
Wow.
So
It's amazing. It's amazing. It gets to 6 miles, isn't it? That's just incredible.
Well, I think it'll go a whole lot further. In fact, I left some retro reflectors with George that
Oh yeah, I remember you saying that.
I think he plans to mount them all on a piece of wood and really, see how far you can go with it. But here, I'll just show you that these are just videos of like us doing this, so it's not the actual recording, but we'll try getting the sound into it too.
So what is that thing of sound? Is this thing you're looking at now? It's a what did you call it? This super duper thingy with the enormous lens on it?
That's a telescope.
It's a telescope. All right.
Stanley, you're back on?
Yeah, unfortunately, I'm going to have to run. Hopefully, I'll be back before the hangout's over. But I'm going to. That's a telescope. It's a Schmidt-Cassegrain telescope with my Sony attached to it.
Oh right, so it's an astronomical telescope.
Yes.
Ah right, I see. Massive. So there's a mirror job in there, is there?
Yes. Yeah.
Right. And what was that, 6-inch lens or something on there? Is it, or 8-inch or something?
It's 8-inch.
It's not a lens. It's not a lens, of course. A mirror, 8-inch mirror.
Yeah, it's an 8-inch telescope, and I have a 42 megapixel camera on it. Basically.
Wow.
Unfortunately, if you don't get sharp focus, though, the 42 megapixels goes to waste.
Pick up all this piece.
So I'm gonna have to take off for a little bit.
All right.
Okay. Bye, Stanley.
We'll see you later. Let's see what else we got.
That lens, just seeing that 6 miles, that's amazing for the. You say you put the reflectors, yeah, that's just amazing. You can get something out there and back again.
Where is? Oh, here we go. I don't know if this is a movie. I'm just kind of going through these for the first time.
Right. Yeah, that's fun. That's fun, Jesse. Just take your time.
Time lapse photos of
Someone's. We can barely hear someone. Is that's the narration on the video? Is it right?
George is about to get his camera lined up to take photos through the telescope.
Hey George, did you depict that tree so that you could climb it? It looks as though it had remarkably convenient branches at sort of every foot, sort of few feet up, just so you could climb it.
Yeah, I was rather lucky that that particular tree had to be was just right lined up with the targets.
Brilliant. Well, that's very fortunate.
The white pine. Yeah, it was a little bit off from where I originally had the target set up, but it was still close enough to be in line with all the targets, which was rather fortunate.
Yeah, I mean, amazing little the branches. I mean, amazing on a tree that size. It had little branches that were conveniently placed. Normally, a tree that size, you get the branches every sort of 10 feet or something. So you're rather fortunate. It's like a ladder you had there. It's great to see you climb that, though. I was always because I thought you were going to have to do that, and then of course you've got to site that with that. You then worked out when you took measurements. Presumably, you then had to work out where the water was relative to that by taking another measurement or something. Did you?
Well, the way I originally did it is I drilled a hole in the ice and I mounted my TopCon total station down on the ice, and I mounted a corner reflector up on the tree. So then I shot from the water to a spot on the tree and then measured from that spot on up to the target.
Right. So once you've done that, you knew what the position of the target was relative to this thing. So that means you could just measure to the water, and then you knew how much it was above the target was above a point above that.
Right.
Yeah. Right. So that's, yeah.
And we're able to even get a much better measurement on the height. Jesse and I went out with his equipment on Sunday, and we measured the center heights of all the targets to the water level using his equipment. And he Correct me if I'm wrong here, Jesse, but Jesse said that it can be. We'll know the heights within a centimeter or less.
Because yours is 30 times, isn't it, or something, George? Your magnification is 30 times. It's Jesse's much higher.
I think you're talking about the positions. We took readings on the ice. I would say they're probably good to a couple of inches.
Because the precision in the crosshairs, and you can adjust greater, is it? And you got greater magnification.
This wasn't optics. No, this was optics. This was using GPS equipment that Jesse.
Oh right. Oh GPS. Oh I see. Right. Sorry. I thought you were looking. I thought you were guessing high res. Lots of scratching going. Is that you, George, or Jesse, or someone? There's incredibly scratchy noises. Did you take your equipment, Jesse, with the higher magnification or did you just use George's station?
I'm showing you my Wild T2 right now.
Oh right. Wow. Lovely.
What I would do normally is take a screenshot of that.
Right. So, and you can get your. Have you got a bigger lens? Because George obviously struggles to get his camera looking through the lens properly.
It's just my phone holding it up to the telescope.
Oh right, I see. Okay.
Nice. Oh, look at that. Yeah. Ooh, that's a clean shot right there. Nice.
Mm.
All right, let's see what else. I was playing some of these just a little bit ago, and someone said in the chat that I was not sharing my screen. So
Yeah, you weren't. No.
So we'll do them now. I don't know why that happens. There we go. Rumpus, see, there's that big lens there. Did you see that?
No, I missed that. Sorry.
I'll back it up. Look at that. See that?
Oh, bloody hell!
Yeah.
No messing. Wow. That's fantastic.
So I've got my headphones right now. I've got my mouthpiece is into the earpiece, so you can hear the video. Hey, George.
Right. This is obviously this is at dusk, presumably, so you could see the laser. This is the laser sighting rather than your right.
Right. That's
how far did it diverge then? I mean, were you able to verify how big this the thing had got by the time did it meet the specifications of the laser? I mean, it looks like it's better than the specifications of the laser. I mean, I'm amazed it's doing as well as it is.
George would have to speak to that. I know.
Yeah, George, that laser looks like it's doing quite well.
The divergence on the laser is about 1 millirad.
Is that you've measured, or is that the spec you mean?
I've measured it, and that is the spec, but I've measured it and verified that it's 1 milliradian.
Right. And that means when it's down to that 6 mile target, how big is it? How big's the?
About 30 feet across.
30 feet, right? Gosh. Right.
I don't know what this one is. Let's find out.
But keep in mind that what I'm shooting, the target I'm shooting, is 2.5 inches in diameter.
The target you're shooting at is 2.5 meters. Did you say? Sorry.
No, 2.5 inches. The corner reflector that's reflecting back that light.
Right.
Is
right.
2.5 inches in diameter.
Right. So it's amazing. It's
only shooting a very small portion of the light back that's being received out there.
Yeah, that's why it looks so small. Yeah. But just looking at the video, just looking at the laser beam, it to me it looks as though it's hanging in there quite well actually. But if you're saying it's 30 feet at the end, okay, that's obviously perspective and all that.
Yeah,
Are
because
you able to
looking
hear
at
the,
just
audio?
figuring it out, the ratio on the diameters, you're looking at only 1/21,000th of the light is being reflected back.
Right.
Can you let me know if the audio is coming through on these videos?
Very quietly.
I don't know how to turn that up.
Yeah, audio is always tricky unless you're using these virtual audio cables and things. You can use a piece of software that emulates a pumping your output to your input. It is tricky to get the audio. Yeah.
One little gust of wind makes it shake so much.
All right. What's that? That's looking.
900.
Oh, that's right. I see. Okay.
Because that you had that set to just take time.
2018. Looking at the lower targets, this is the Bedford level type test.
Is someone else playing something?
I think that's George.
All right, the P900 is taking time-elapse photos of the targets.
That's clear.
George is about to get his camera lined up to take pictures through the level telescope. And Lance has gone back to the hardware store to get a bolt or something to mount his telescope.
Ah, right. There's a telescope.
So we'll have that going as well. Here's a retro. Here, I'll show you. So we'll have that going as well. This right here, Rumpus, that's a corner reflector. It's got a plastic cover over it, but it's just it's glass in a prism pattern. So reflects the light back.
Yeah, I know George had one, didn't he? He had the one originally. Yeah, I saw that, and then you went along with another 4 or 5 or something, didn't you?
Yeah, this is just standard surveying equipment.
Yeah. Do you still do this then, Jesse? Do you still use all these reflectors and things now? Is it all GPS to you?
Well, it's primarily GPS, but we still do a lot with total station equipment and reflectors. Yeah, we still do.
Right.
Con, I love these shots of Con.
Yeah, I think I had a look at in detail that one that when someone claimed that the FE core thing was the longest one. I think you gave a link to some project in the 70s or 80s, didn't you? That had the very long.
Oh yeah. That was the McDonald Observatory.
And you actually went through all the notebooks, didn't you? You actually found the original notebooks and things.
In fact, if you looked at the photography that was given to me by the person that was there, and he was one of my mentors. So
right,
we did things way back before GPS.
Yeah. That's amazing stuff, and the amount of effort. I mean, it was about 6 people or something, and goodness knows, and presumably what did you allow for refraction in those sorts of situations?
I think he approves.
What did you do about refraction? I can't remember now. There was some mention of it, and I can't remember what the allowances were for it in that project.
Yeah, if you read that report, they did a good deal of study on refraction.
So didn't they fire it at one another or something? That you actually
what
cancelling it somehow by looking at one another or something.
Correct. If you have 2 theodolites looking at each other, measuring what's called reciprocal zenith angles,
right?
The idea there is that the refraction would cancel out because you're simultaneously observing through that medium.
But doesn't that just? I haven't. Yes, I meant to study that, but I didn't. So that I don't quite understand how that works. But perhaps I'll have to go and study it. But so how does it? I would have thought you just simply both would be affected by refraction. I don't quite see how. Unless you're assuming the curvature of the Earth. No, I'm confused.
I could send you something about it.
Oh well, I'll be fascinated by that. Oh, by the way, I'm trying to myself and someone else is trying to do the refraction calculations, modeling it using equations and creating ray diagrams. So when George gives me the thermistor stuff, we can actually pump those values into there, and we hopefully could then model exactly what the rays are doing that George is from George's information.
I have a ton of documentation on refraction.
I'm pretty
I'll
close.
link you to a Google Drive. And,
Oh right, oh great, because we're trying to do this, using the math. I don't know if you're familiar with the maths about it, things like calculation of variations and the lapse rates and things. And you can actually, we're able to get. We're trying to do something. This Isle of Man thing. I can't remember how much you've seen about that, but we're trying to emulate the reproduce in maths, knowing the lidar data, or actually the shuttle topography data of the Isle of Man. We're trying to emulate what you would actually see using the lapse rates and things and information we know about the day. But of course, George is doing it even better here, because he's actually taking thermometer temperature readings all the way along the optical path. And so armed with that, we can know the lapse rate exactly. And so in theory, we should be able to emulate exactly what George is and you're seeing through the auto levels, etc., and reproduce them exactly in theory. And we're having some success with the Isle of Man stuff. So, but obviously we haven't quite got the information that George has got for this thing. But it would be fantastic to repeat this.
We have a large data set here that's worth investigating and studying. But let me show you this. You'll see George up in the tree, I think, here.
We always like to see George in the tree.
Well, it's me trying to record the shot while he's up there.
Yeah, it's incredibly convenient, that tree, the way it's one of those branches.
Sorry for the bad focus here.
There was something else I wanted to say about refraction.
Almost done, George.
Oh, that was it. I was also. Yes, I was also.
Did you hear that?
No, sorry, I missed.
Starting to fatigue.
Oh right, George is tiring, is he? Yes. One thing I was also going to try and do for this thing of model it in Autodesk. Actually create a 3D, or actually create a 3D model of this experiment of George's.
The audio on this video.
I could hear a little bit of it.
April 7th. This is Monday, April.
All done.
I think I got about 6 or 7 shots. He was definitely relieved to hear that it was all done. Let's see what this is.
This is Monday, April 9th. Looking at the 10th.
Is that you, Con? Is that you, Con?
The neighbor's dog.
Con?
So here we have the full moon coming
Con?
up. And
Oh, you're not Con.
I'll tell you where we are. We're on George's dock, which extends out. We've set the level up.
April 10th.
Same height as the 72-inch, 73-inch targets. And I'm going to show you some pictures.
It's snowing. Really good companion. Full dock here. Good, that's buried in the ice. The rebar.
Hey, George, just let me know when you're ready. I'm kind of vamping here. Let me know when something.
Yeah, I'm just looking through some of my video here, trying to pick out a few representative samples.
Here's us partying.
What is Khan doing? Oh, we've got some Pink Floyd on. Dark Side of the Moon. Oh God,
Khan is begging for food.
That is one hell of a
He
beg.
knows how to work the room.
Take it away. The moments that make up a joke.
That's one hell of a beg.
All day.
You don't want to hear me singing.
So as I was saying, hopefully I could. I don't know. I would like to create an Autodesk 3D model of all this, so you could sort of swoop around in virtual world, and and then apply these refraction equations to get the images that you see as well. Ultimately, oh, George is bloody sipping on his bloody cola, isn't he? That can't be good for you, George. That really can't.
Let's see where this is. I don't know why that keeps thinking it should be so big.
Don't worry, Rumpus. While Sonley and Jesse were here, I only went through 24 liters.
Oh my god. Oh, George, I hope you're getting enough exercise to consume all those bloody calories and things. Well, I suppose you're climbing trees, but bloody hell.
George had to go back and see about Lance's drone. It looks like it went up in a tree or something. So I'm out here at the third post. I guess I'm about 3 miles or so out here. It is like Arctic conditions. And it's bad. It's really hard to work in this. It's very high.
You see, let's comment about Debbie making a bedroom level experiment. Oh, so. There's this silly bint called Debbie who's been infected. Flat Earth has been infecting various hangouts.
Ooh, let's see what we get here. Yeah, I don't care about Flat Earth anymore.
Today is Wednesday.
This is just fun. Nice.
I think my body's trying to figure out how to adjust yeah. Because at first my hands are cold, now my hands are fine.
You mean that?
So my feet are starting to get cold. Oh, the trick there is to move around a lot. What's that? What is that?
I say best to move around, not stand, because as you stand, it sucks the heat out of your feet.
Yeah, I got you.
And get your toes to wiggle and walk, and that helps.
So how cold was it when you were there, Jesse?
Pretty daggone cold.
It's -9 Celsius.
Oh, right, okay, that's fairly nippy. That's fairly nippy.
April?
This one I showed, I think.
On level.
I thought I had sorted these by largest. Where the heck is the snowmobile ride? Huh.
Looking now at the bar number 2 reference.
Oh, here we go. This must be it.
Oh, this is you're driving back, is it, across the snow?
Yeah, this is the ride back from the 6 mile, and I did one continuous video. It's 12 minutes long. I don't think I'll do the whole thing, but I do want to show you Con coming up to greet George at the end for sure.
I mean, this is the thing. Looking at these things that George has done, and you've been done here, you suddenly the scale of the way you appreciate the world works. When you've got a big flat plane like this, I mean, suddenly these distances look really weird. You know, you're going along and this is a mile away, and it just suddenly everything's being compressed. And you suddenly don't seem to be making that much progress as a sort of target, you know, 5 miles away, and you can see it, but you're not getting there. It's a really weird change in perspective you have in this environment that George has got going here.
Yeah, you'll see. We kind of pause at each target on the way back, or no, that was on the way out. We collected all the lanterns on the way out to the 6 miles. So this is one
the day
ride back. Here we go.
Oh, yeah.
I try to film the speedometer.
Right.
But I think we're doing like 50 miles an hour.
God, yeah, George charges over this at mad speeds. He was doing bloody 70 in the car last year over bloody rocks and what appeared to be sort of hillocks and things in the ice. Incredibly dangerous. You're doing really well there, Jesse. Actually, I'm impressed with your camera work given the situation. Some good panning shots there.
Walkie-talkie? Huh? You have your walkie-talkie?
Yeah, they're in the bag.
In the bag?
In the red bag. Right,
Yeah.
right behind us on the snowmobile. Look at this crack.
Yeah, cracks there, yeah. Scary stuff.
Well, this is something Con really loves to do. Look.
Bloody hell, that looks a bit thin. What? Could you really be doing that, George?
This ice is about a meter thick.
Is it? Okay. I suppose it's just the snow's been cleared, I suppose. Right. Just imagine if you were trying to do this on water instead of, as George has done, as picking the ice. I mean, it'd be an impossible task. It'd be spending so much time trying to get from A to B and mounting things and sticking things and getting on and off boats. Getting on the ice just makes such a difference.
All right.
What a ride. Oh. I has not seen George for an hour or two. Oh, he's so happy.
Oh. Yeah.
He's so happy. Where have you been, Daddy? Where have you been? Oh, I know, Cub. Oh, he's so happy. Now look, he checks out the load.
Yeah, he's like, he inspects everything. Yes.
Boy, Con, huh?
Yeah.
What you seeing, huh?
He's ready to do something.
Oh,
Yeah, he wants a game.
Come on.
Oh. He's a lot of fun, isn't he, old Calm?
Oh, he's a good boy.
He's a good boy. So at one point last year, I think George was saying he refused to come out on the ice with him after he had a couple of incidents or something. So he does have some criteria of that he's not prepared to go too far sometimes with George.
Let's see. So I could show pictures, George. Are you ready to show something?
I'm getting there.
Okay. Let's see. I will then sort by name. And let's see if, what am I doing? I want to look for, let's see.
Today is what?
I'm going to have to go shortly, Jesse. So if you could just give me those links you were saying. I mean, just put them in.
Oh, I will. Hey, yeah, send me a message and
I will. Okay, so because
I've got a huge collection, and I'm glad to hear you're interested in studying the refraction, because I am as well. I was telling George, today surveyors, we don't, I've been trying to get this across to people that we no longer measure 10-mile distances.
Wednesday, the 11th of April.
Everything's like 500 feet, 1,000 feet is like a long line.
Yeah, I can imagine.
Primarily GPS with everything, and we use robotic total stations to measure very short lengths. So refraction really doesn't come into play on these distances. And anybody that used to deal with that, I mean, they're much older today, they're retired,
or set of targets.
It's not something we deal with regularly. Jumping into this whole flat earth thing has given me an opportunity to kind of look back in time and learn more about that. So I'm interested. So if you,
well, okay, well, I'll be having a hangout with this guy, which is doing this simulation next 2 or 3 days. But yeah, okay. So if we are going to say anything interesting about refraction and modeling it, then I'll send you a message or something to see if you're interested.
Yeah. Listen, just look at this picture before you go. What you're looking at here is a little bit off the line. So I'm not looking straight down the line of targets. By the way, these are the lanterns. We put the lanterns on.
Oh, right. You'll know the lanterns. Yeah, right.
Yeah, the Little Tinses Bayou lanterns made the trip. So Sally brought them, and here we are. This crosshair is set up at the same height above the water as the lanterns. And this first one over here. Now this level has this type of crosshair and then a wedge.
Right.
For special purposes. And so I'm trying to find one where this is the closer one. But these are the far ones, and they're all below, the horizontal tangent.
Yeah.
But
so this is actually we're looking at a horizontal here, are we? Those crosshairs are on the horizontal. You've leveled the crosshairs, have you?
That's correct. This crosshair is the same height above the ice as the lanterns.
But are the lanterns the same height as you at the eye level of the whatever you want to call it, the theodolite or this auto level, whatever it's called?
Yeah. These are all. I forget what we did. The targets are 73 inches above.
Right.
I think we set the lanterns all 16 inches above those, and I think it was like 89 inches. But don't quote.
And then you set the theodolite eyepiece at the same level.
Correct.
Right.
And so this is the closer one. I think that's
right.
Miles, and these are all dropping away.
Gotcha. Right.
You see, they're dropping away. And
yeah.
Some people they measure pixels. I mean, you could literally measure the drop there.
Yeah. And so how far was the furthest lantern?
Well, let's see here. This is the 0.7. George knows the actual distances.
Are these on the target? They're next to the targets then?
Yes.
Oh, right. I see. Oh, to 2 miles.
The lanterns, we strap them on to the posts.
Ah, right. Okay.
all
So
of
they're at 4.1 whatever miles, 6 miles, and right, and 1
well,
point
this one
whatever it
would
was.
not be the 6 miler isn't involved here, but
Okay.
it would be the series of the 0.7, 1.36, and etc. I don't know the distances by heart,
Right.
but what I'm going to do is I'll make a chart with the actual positions of these and whatnot. So tonight is just kind of like
Yeah,
looking at the raw stuff.
having a play. Yeah.
But got some good shots there.
Yeah. Great.
There's
That's a good shot. Yeah.
so these are pictures I actually posted in my Facebook group, Flat Earth Can't Geodesy. Yeah,
Right.
we just wanted to keep people aware of what the progress we were making and things we were doing. It was,
I'd like to see Carlos fully joining in there.
yeah. So, all right.
Yeah, he didn't want to give up his position on the couch.
Oh, right.
He was happy to lay his head on whoever was sitting there, so I had a chance to be a pillow for his head.
Oh, great.
All right, I don't know what else to show, George. I hope you're ready.
Yeah, I'm ready.
Oh, good. All right, man. I will give it back to you. One second here.
Oh, pardon me. Excuse me.
All right, sir. It's all you.
Second here.
We're just looking at your beautiful face right now.
Huh. Oh,
Need to screen share, George. There we go.
There you go.
is it coming through now?
Yep.
Yes. And I'll go check the live out there. Yeah, you're on.
Okay, let's see here. What in the world?
So why hasn't it stopped doing this super zoomy repeated thing?
Now, the auto level is up at the observation point.
Let's see here. You can see an awful lot of shimmer.
We have some refraction going on.
This is what it tends to be like when the air heats up above the ice. You get an awful lot of shimmer.
Real good view of targets.
You can see that the targets in the distance rise up. Like here, if I stop at this, are you seeing my arrow okay?
Yeah.
Yes.
Yep.
Okay. This is the 1.36 mile target. This is the 2.72 mile. This is the 4 mile, and this is the 6 mile. So as you see, these are all lined up on a no refraction condition. They'll all be lined up with the horizontal line, but as you go further and further away, the targets rise up higher and higher because of the refraction.
Right. So, George, I think I asked you a question on Hangouts. Have you aligned them? How have you established the no refraction case? Did you do that by just presuming these? I mean, we discussed this last year, but I can't remember quite how we sorted this out. How you could identify when there was no refraction at all.
After observing on every day for the past, last year I did it for close to 60 days, and this year I've been doing it over 40 days now, and observing every day. I've learned to identify when refraction is at a minimum, and then on those days that I think are the best, I run out with the thermistors and measure the optical corridor to verify indeed that I have low refraction going on.
Right, but you obviously don't know that it's no refraction. You just know that it's minimum refraction.
Minimum, yeah. I mean, there's never going to be zero refraction.
Exactly, that's my point. Yes, unless, well, of course, you could establish if we secretly sort of said, well, we know that the Earth is obviously this shape, and therefore you could position the target such that you would then say, well, if there was no refraction.
On some days, I mean, it's very close to being zero refraction, I'm sure. because when you look at the temperature profile going over 6 miles, you're not seeing the temperature vary more than a couple degrees Celsius.
Right, but I think if it's, I can't remember what gives you no refraction. I think a couple of degrees might be enough to give you some sort of looming.
Yeah, there'll be some. But
Yeah. I'll try and do them. Well, hopefully we'll be able to give you some answers on this actually in the next few days, certainly within a week, to tell you what we think from Philip and myself, whether or not something like that would give you next to nothing or not. But of course, you can obviously verify this because we obviously know that the Earth is a sphere. So I don't know whether you were tempted to actually position the poles in the spherical position and then say, right, and then say, oh, look, I'm never going to get them in a line because there's never zero refraction.
no, I wait for minimal refraction and adjust the targets accordingly.
Yeah.
And
Right.
we haven't determined yet what the heights. I've got the heights, and I haven't sat down with Jesse and have the precise distance measurements and that, so we can see what the particular contour shape is. You know,
Right.
whether it's following the 8 inches per mile squared or just what. You know,
Okay.
we
But
haven't got.
you've done the
We
thermistor.
have the data. We have the data where that information could be extracted, but haven't had the time to do it yet.
Right.
I'm drilling with.
This will give you an idea of
last
the
hole that I need in
thickness of the ice and the quality of the ice.
Jesse had his.
This is right by. This is where I'm drilling a hole where Jesse had his reference for the GPS, and you can see there I haven't punched through yet, and we're at 24 inches.
Bloody hell. I love that auger. Did you get your chainsaw fixed in the end?
No, I think it's trashed.
Right. But you got some snowmobiles going anyway, or did you hire them specially for Jesse and Sandy?
No, there were issues. One of them was leaking coolant real bad, and the other one the track.
Oh my God! What is this with snowmobiles not working with you?
The quality of the ice here is really good, you know, and I haven't punched through yet.
God,
like I say, at that point it's 24 inches.
That looks like rock, doesn't it? That looks really solid.
Yeah, let me tell you, I was really nervous driving on that. I've never experienced anything like that before.
Oh, Sandy's back.
Yeah.
And George was like, "Yeah, you can drive out on the ice," and I'm like, "What?"
Yeah, 70 miles an hour he did last year.
Sure about that?
Nearly killed himself on several occasions. I've got the video. I've got all his videos, and several of them were nearly killing himself at 70 miles an hour, going over some humps and things. Knocked the rear bumper off his car in the process, I think.
Oh, no.
Madcap George.
Well, we're about to the conditions now where I can take the car out. There isn't much snow on the ice, so I should be able, probably this weekend, be able to drive anywhere I want with the car.
Great.
What the heck? It's sure taking a long time to load.
So you've got all the thermistor readings then, George, for some observations, have you? So you've actually got a set of observations you're happy with, and you've got the thermistor readings for them as well.
Yeah. Yes.
Brilliant. Absolutely brilliant. Okay. We should be able to model that then.
Oh, here it comes. Okay, now this is the start of the Bedford level type test, you know, readings. And
by that, you mean that your level crosshair is set up 73 inches above?
That's right. Here, let me freeze it.
That's beautiful. Look at that. See, things really do drop down.
Now, at this point,
so
the bottle level is 73 inches above the ice, and it is leveled, and this is the 0.7 mile target.
Right.
You can see that it's a little bit below the crosshair.
Yep.
Which at 0.7 miles, let's see, what would that be? Third time. So you're looking at about 4 inches that it would about drop. And if you look, let me tell you what, if we look at the width of the target from top to bottom, let's see here.
Soundly, you seeing this?
Yeah, it's nice.
George, you really did it. I'm really happy to see this.
Yeah, it's good, isn't it?
That's great.
The width of that target, let's see, 2 inches plus 1 7/8. Here, 2. 7 8.
Okay, so while you're working that out, so we got this one on the right hand side is the nearest, then presumably the next one is the one on the left, and then the third one presumably is on the orange pole in the middle, and then so it goes over to the left again.
What we have here is all right. This one is the 0.7 mile target.
Right.
This is the 1.36 mile target. This is the 2 mile target. This is the 2.72 mile target.
Right.
This is the 3.4 mile target, and this is the 4 mile target.
Right. It's great. It was such a
These are
great
all
idea.
at 73 inches above the ice.
Right. So great when you can get them all on the same picture, isn't it? It makes such a difference when you went for that last year to get them all so you could see them all like this. It gives a nice graphic representation of what's going on that anybody can understand.
Some other days. This one, even though targets better than they should be, they're still dropping down, you know.
Yeah. And this is your P900, is it? Or, sorry, your high-res camera footage looking through the auto level, is it?
That's a nice.
Let's see here.
You're breaking up a bit, George, all this time. Don't know whether that's me or you.
Oh, sorry. Here, hang on. Okay.
I do have another video I'd like to share. Just a context video, really.
Let's wait. Let's wait till we see all these shots.
Yeah, I was just mentioning it.
Yep. No. For
Okay,
sure.
this is another day. This is on the 9th, 3 days ago, on the 73-inch targets.
That's nice and clear. That's high res, yeah.
Again, this is the 0.7 mile. This is the 1.36 mile. This is 2 miles, 2.72 miles, 3.4, and 4 miles.
So, and could we take a sample measurement here? So, for instance, something like that one in the distance, the one furthest away, how big's that target so we can work out what the angular...
I will be doing on a good day is I'm actually going to measure with the total station, the actual angular measures.
Right.
But that target, I have the numbers someplace, tell you the exact width of it, you know.
Yeah, because then we could it'd be nice nice to do a little pixel count here. We could just
sure. But
never mind.
I have a lot to dig through yet.
Yeah, you do. But I could perhaps save it for another day.
But I mean, I have all that, you know, as far as
of course
the
you do,
target
George.
sizes and that, you know, all that's very well documented.
I know. I can imagine that, George. Oh well, I'm gonna have to go to bed anyway. But that was fantastic stuff to see anyway. The nice raw footage, and I'll yeah. So I'll get back to you, Jesse, about this refraction stuff, and
Absolutely.
and I'll try and keep you up to date with any developments. We're just sort of getting stuff working now on this Isle of Man thing, and it seems to be we seem to be getting our refraction calculations such that we can reproduce what you actually see based on the shuttle topography data of the Isle of Man.
Make a note of. Notice on each of the poles how I have it banked up at the base. You know, the snow piles.
Yes.
See, you can see these okay, but now this one's starting to disappear and you don't.
Breaking up a little bit again, George, I think.
Target is hidden by the curve of the earth here.
Right. Yeah, you're breaking up. We missed half of what you said then, George. You're breaking up.
What, Rumpus?
You're breaking up. We only got half of what you said then.
Oh, I'm saying notice on the bases how I have up on the poles.
Yeah.
Are you hearing me okay?
Yeah, we heard that. Yeah, that's the bit we did hear.
Are you hearing me? All
yeah,
right.
We are.
No?
Yeah, we are.
Okay. Well, as we go further out, you see less and less of the snow pile. And out at the 4-mile target, the base is hidden by the
and obviously
curve
we can see the targets have gone downwards. Obviously, so presumably we can presume therefore the base of the poles has gone down as well. And that's I suppose that's a good point actually. That is the 4-mile one the first one that's over the horizon. Presumably the ones these are ones the ones on the two on the left, presumably they're not actually at the base of them are not actually over the horizon, presumably. Or must they be? I'm getting confused now. Because they must be if they're going down. No, they don't have to get that much. Anyway, it's a bit late for me. Yeah, so yes, I mean the horizon. So this is taken from whatever it was. What your observation height is. You're breaking up again. Was it me?
Oh, what's happening? Everyone's breaking up on me. Or hello?
Yep, we can hear. I can hear you, George. I don't know about other people. No, I can't do it. I don't know if you're speaking now.
Hey,
Hello?
George, can you hear me?
Yeah, I hear you, Jesse.
Okay. Hey, question. The 4-mile target is the red one, the orangish one. Is that one set at 73 inches right there? Were both? I forget if both targets were orange, the high one and the low one.
Yes, they're both the same color.
Okay. So that lower one is at the 73.
This is no. This is after I removed the top portion of the 4-mile target. I only have the view. There's only the 73-inch target. If you notice, the pole is no longer blue-green. This is now, whereas before it was on one of the 2x4 strapped to it like this one.
Yeah, understood. Okay, so that's a 73-inch high target above the water.
Yeah.
Gotcha. Okay.
Okay, I think I'll leave it there. Great stuff, George and Jesse and Soundly, and hopefully I'll see some more of this later.
Alrighty. Have a good night.
Nice.
Good night.
See you, Rumpus.
See you, George.
Take care.
Night, Rob.
Okay, let's see, 14, 20, 39. Let's
George, quick question. Larry is asking in the chat if in addition to temperature, did you also record barometric pressure?
Yes.
Okay, Larry, yes.
Yeah, it turns out the barometric pressure, it varied a little bit, but not very much. I saw was maybe 30.10 inches. It might have been 30.2, a tenth max differences.
Okay.
Jesse, you know how you have those receivers that record GPS data, and,
Mhm.
and you set them there, and they just take a bunch of readings. And are there any modules that you can attach to those to also record weather data? Same time.
Well, I mean, you can get pretty decent handheld or portable weather stations. Is that what you mean?
Yeah, I was just wondering if there was like a convenient module that you could add to those where it's all recorded in the same.
Oh, yeah, I don't think so. But they're those GPS receivers are getting more and more compact. But I know you can go online and find really nice. I mean, they fit in the palm of your hand. Pretty nice weather recording devices. They all, some of them even have a little port for getting the wind speed. So
Nice.
But let's see what Larry's all into this. Yeah, Larry, we were talking about that earlier. That we would never find a condition where there's zero refraction. So.
Noted now the TopCon total station behind is for a second type of Bedford level test that I was doing for Jaron of Globebusters, where he wanted me to rather ways it's doing things. Let me show if why isn't this stopping? Okay, if you see there's a pole here. This pole is about 100 feet away. This is around 400 feet away. And I have marks on each of the poles that gives me 73 inches above the water level. And then what I've taken the TopCon auto level, set it inches above the water, and just verified by citing this 70 that the 73-inch marks on both of these poles line up with the 73-inch on level.
Okay.
And
George, hey George, hold one. I'm going to repeat that because you are breaking up, but I'm going to just repeat this for everyone who's listening. George has some reference points set nearby that are 73 inches above the water level, and he's able to just verify that his instrument is set at that height by viewing those. And I guess you're going to show us that, and then you'll show the further sightings. But that's good. So you have some close by references that are at the same height.
Right.
Good.
And then what I've done here, this is for Jaron of Globebusters, is I've mounted another tripod behind this to put the total station on. And what he wanted me to do is cite the 0.7 mile with the 1.36 mile target, line those up. But you can't do that with the auto level because they're not lined up with a tangent to the earth. It would be if it was a flat earth, but you can't make the auto level line up the 0.7 and the 1.36 mile targets that are both at 73 inches above the ice. So I had to use the total station because it has to rise up a little higher than the auto level and shoot downward. It turns out the amount that it has to shoot downward is about 30 arc seconds in order to line up the 0.7 mile and the 1.36 mile target.
Gotcha.
So today is the first day that I was able to start doing that. So over the next few days to the week, I will be using both the total station and the auto level for recording these Bedford level type tests. One in which the auto level is sighted at 73 inches, shooting a target or a tangent out to the earth at 73 inches, and then one using the total station where I'm sighting the first two targets together and then looking at how the others line up.
Understood.
And then I'll also be recording zenith angles and target widths with the total station. That'll be kind of interesting data to use, so that with the distance measurements that we have between the targets, we should be able to use the subtended angle, the perspective equation. Basically, subtended angle is the target height divided by the distance,
Yep.
So we should be able to, hopefully as a second check, verify that the measurements are good,
Absolutely. You have the positions on the targets. Did you want me to calculate the distances between them?
Yeah, that would be nice.
Okay, I'll get on that.
Yeah, because the distances that I have is using the latitude and longitude coordinates that I have from my handheld GPS, and your measurements are so much more precise. It'd be nice to have the good numbers.
I'll get you those. Yep.
And it also helped me determine, what the resolution is, how much faith I can put in my handheld. I know that from previous experience and tests that my handheld's probably good to about 4 or 5 feet, but no better than that.
Yeah, that's what I figured. So, okay.
Let's see here. So this is kind of a view of the setup for the Bedford level experiment. I don't know what else to call it, so that people know that when I refer to the Bedford level experiment versus the tangent experiment, is there's two types of targets out there. There's the upper targets that are lined up with a tangent to the earth at the upper observation point up on the hill. And those targets are lined up to be the centers of the targets with a tangent to the earth. And then the lower targets are all the same distance above the water level. And so I'm have the instruments, the auto level set up at 73 inches above the water level and shooting the lower targets. And if the earth were flat, all the targets should line up. And what we're finding, of course, is that the targets do not line up, that they're dropping further and further away from the 73-inch tangent line as you go out further, which, of course, is what you would expect on a spherical Earth model, or a non-flat Earth model anyway. And the instruments are pretty much verifying that. Again, you can see an awful lot of refraction here going on. This is later in the day. This is a sort of problem that you have. In fact, looking at this, you can see how much refraction there is. Let's just freeze it here. This is the 0.7 mile target. Earlier in the day, the crosshairs was going through the center of this target. So even out at 0.7 miles, the target is raised way up from where it should be because of the refraction.
Yeah, and let's talk about that for a second. So refraction doesn't make the Earth look curved; it actually flattens it out. That's everybody wants to bring up refraction, and you're looking at something here where uh, it's working against the curved Earth, and it helps flat Earth. They should realize that.
Yeah, in fact, Hnatiuk here, show you. I'll freeze. Let's see here. Okay, freeze it here. It's hard to see the targets because of all the refraction, but this is the 4 mile target. This is the 0.36, 2 mile, 3.4. Earlier in the day, I set the auto level, adjusted its high inches. It was going through, it was just a little bit above, about halfway. You'd expect that this target should be a little bit below 73 inches because it's out at 7/10 of a mile. And so earlier in the day, this horizontal crosshair was going right about here, just above the black on the target. And all these other targets were below the horizontal crosshair. But now, later, we have a lot of refraction well above, whereas today, all these targets were down in here, below the crosshair, below the horizontal crosshair.
You just proved concave Earth, George.
So it just goes to show you how much the how much refraction will raise the targets up.
Concave Earth. Now we'll be fighting all the Lord Stephen Christ followers.
Yeah, but look what a blurry world you have to live in. Everybody needs new spectacles. You have to wear glasses in that world.
Yeah, that's what I've noticed, just through my own experiences, is that in the best seeing conditions, in the ideal seeing conditions, and you can see the furthest, the clearest, with less turbulence, it matches the globe model. Almost exactly.
Yeah.
Okay, this is earlier in the day, as I was telling you, is if you look, the 0.7 mile target is a little bit below the crosshair, but definitely all the other targets are way below. Whereas what we were just seeing in high refraction, all these targets were way up above the horizontal portion of the crosshair. This is one of the best conditions I've ever seen. If you notice, this is live video and you don't even see any shimmering going on in the background.
Hey, before you move on, George, just pause that right there. And once again, go through which targets are which with your mouse pointer.
This is 0.7 miles. This is 1.36 miles. This is 2 miles. 2.72 miles. 3.4 miles. And 4 miles.
Thank you.
This is one of the best shots I've ever had. I mean, there's absolutely no distortion out at 6 miles on the far shoreline here.
It's a great shot.
George, I was actually thinking about that. Remember when we were out there picking up the lamps, like what the ground actually looks like right there? Because I think that's completely hidden, the bottom of those rocks.
Yeah, you don't see the bottom at all. All we're seeing is the upper portion of the rocks.
Question in the chat from Larry was if the auto level had been calibrated recently, and I answered back yes. But George, do you want to speak about the lengths you had gone to get that thing so tight and so close the way you did?
Yeah, I'm going to do a video on that. One of the updates, I have actual video footage of me calibrating it. And, I checked the calibration. What was it? A few days before you and Sony arrived here.
Yep.
So that was about 2 weeks ago, is in which I checked the calibration.
Noah Allen. Yeah, you might want to watch the beginning of the video, because the upper targets are all essentially lined up to be on the tangent line from the observer, whereas the lower targets are all relative to water level.
Yeah, Noah Allen had just joined in, and I think he was asking specifically about the view that we were just showing, which was the lower targets. And like Soundly said, the lower targets are all at the same height above the water, 73 inches. The upper targets are set basically on the tangent line, aligned to the crosshair on a very low refraction day. Okay, here's your close by references.
Right. Yeah. I was just getting stuff set up. Keep in mind here that these marks are pencil width. So you're looking from here to here. We're at about a 1/16 of an inch. But I was doing some verification on one of the reference poles. Let's see here. Let's see if I can. Let's see here.
Larry, Larry, I don't know if you caught it earlier, but George actually drilled down to the water level, and he measured up from the water level.
Also, I'll get you the links, Larry, to the I forget what it's called, but George has some sites where the lake is constantly monitored, and they're online. And basically, you haven't seen much variation in the level of the lake, isn't that right?
That's right. This is where I do my auto level calibration in the hallway of local high school. From one end of the hall to the other is 481 feet. Here I'm have a laser setting. Let's see here.
Boy, that is one shiny high school.
Now, this is my cal target here on this end of the hallway. Here. Oh, it's sure dragging. Okay, here's my cal target on the east end of the hall. The auto level. Looking down the hallway at the opposite end, where I have the target set up, just like the target on this end. The auto level is adjusted to shoot the center away. Let's see here. And you can see now that the equipment is set up. The auto level has been adjusted. Here's one of the auto levels. This is the CTS Burger auto level. The equipment here, the auto level is set. And I have a target on this end of. See, on both ends of the hallway, I have this type of a target set up. and there's a little gap between two lines here. The gap is 1/100th of an inch. Is my audio coming through okay?
Yes,
Yeah.
it is. Yes.
Okay. Maybe I zoomed in here. There's a gap 1/100th of an inch that I use for sighting. You can see it coming up here. So if the auto level is an adjustment, when I move the equipment down to the other, there, I'll freeze it. You can just kind of see this white gap in here. That's 100th of an inch. And this type of target is on each end of the hallway. And there's a procedure that you go through by setting the auto level in the center, exact center, and you sight and adjust a target on one end, and then you rotate the auto level 180 degrees, and then adjust your target height on the other end so it agrees, and then move the auto level towards one of the ends and sight the target 10 feet away, and then sight the target at the far end. And if everything is set up correctly, you should be sighting the center of the target. If it isn't, then you adjust the compensator on the auto level so that it sights the target correctly. I'll be showing a video. I'll be doing a video on how to calibrate the auto level and how I've gone through and calibrated the auto level and showing how this all works, the theory behind it. So anyway, this was all done about 2 weeks ago to verify
It's good work, George.
So you see the target coming up into view there on the far end. So anyway, it's a great stable environment for doing the calibrations in that hallway.
You said that hallway was about 400 and some feet?
481 feet from wall to wall. Yeah. Let's see.
And before we close out, Soundly had one more video I think he wanted to show.
Okay.
Do you have any more?
Oh,
Not that you need to. I mean, what you've shown tonight is like spectacular, honestly. Like,
well, let's see. This is footage of today.
okay.
This is getting things set up for the second part of the Bedford level experiment. This is using the TopCon total station where I'm trying to line up this target and this target together rather than the two nearby reference poles. And it turned out that was a real bitch to do. It took me over an hour to try to line these two targets up. It turns out with the auto level really does take care of a lot of work for you. And if you're trying to line up two targets by tilting the scope on a total station, maybe my technique isn't very good. Maybe we'll have to talk about that, Jesse, but I found that was a real difficult thing to do.
Yeah, you know what you could have used for that is what's called an elevator tripod. It's a heavy duty tripod, and you know the base that you attach the theodolite to it has it's almost like a threaded crank with a gear.
Oh, that would have been ideal. Yeah.
And you can literally measure, you can move it like a millimeter at a time or
yeah. Because cranking the three screws, undoing them, and then adjusting each leg, and seeing what you got and keep doing that. It was a long, arduous procedure.
Well, you know, also you could think of it this way, that you're literally trying to place the theodolite on a line extended from these two targets.
Right.
And in that sense, there's no need to level the instrument. because you're just trying to create a reference. You're trying to
Right.
just stick that telescope on that extended line.
But I had to level the instrument because it won't read vertical angles unless it's level.
Oh, well, yeah. I mean, if you're just trying to do a visual through the telescope.
Yeah.
Yeah.
But you can see I'm getting closer now where the centers are almost lined up.
Yeah. Well, that's pretty good. It's pretty close. And now, what's the point of this? What's Jaron asking for?
I don't know. For some reason, he wants the line to be established between the 0.7 and the 1.3 rather than using two nearby reference points. I don't know if he fully understands the implications of that or not, but I'll go through that in a video in an update.
Okay. So you'll get yourself aligned to two of the targets and then look at the other targets in reference.
Right.
Okay. All right.
Right. There's two ways doing this Bedford level. Is one is where I'm setting up a tangent at 73 inches above the water level and verifying it with two close by targets at 73 inches, and then shooting a tangent out and looking at the targets relative to that tangent line. And then the other one is I'll set the total station in line with the two nearest targets, the 0.7 and the 1.36 mile targets, line the total station with that, and then look at the other targets in relation to that line.
Gotcha. All right.
So just two ways of looking at it. The using a tangent at 73 inches and verified with two nearby targets, of course, is the more accurate way of doing it. And but I'll have this other one that Jaron wanted me to do, and we should be able to use geometry and verify everything, to verify that we're seeing what
you would expect to see. Yeah.
Exactly.
Okay.
Let's see here. Let's see what this is. Okay, I think this is the one I just saw. Let's do this one. Now this is later in the day. Oh yeah, what I was showing here is what happens with refraction. Remember, we just saw where I had these two very closely, these centers were aligned. Now we can see the one at 1.36 miles rising above it. This target, the center right here, was in line with the center down here.
Yep.
Now we can see that it's rising because no, it just
won't be easy to do.
No.
Yeah.
Yeah. But it's just verifying that I can center up the
Did you cut out?
Yeah, you cut out a little bit.
in conditions.
Okay. So that's what you'll be doing the next day or two.
Yeah.
Okay.
So it's just preliminaries, getting everything set up and making verifications,
Mm-hmm. It's great work, George. Honestly,
Here.
Well, it just goes to show you that a private citizen can do these experiments,
Well, yeah. I mean, look what people are doing just with these tube levels with the red liquid in them, just sighting, looking at things in the distance. It's anybody can think of a way to do these things, but nobody's doing going to the trouble and the effort that George has been gone to. This has been
Level is a pretty dang clever thing for judging horizon drop.
yeah. John McIntyre made a great video. His I guess it's his most recent video. He made a giant one. I mean, I think it's like 4-inch diameter tubes. It's a big long thing. You going to show us some con running alongside?
Yeah.
Yeah, great.
He likes to lead in front for a while to keep me at bay until he gets warmed up, and then he moves off to the side and wants to open it up. This is part of his ritual.
Oh, he's moving.
Yeah, I was able to capture a good video clip of him doing this too on one of those rides. He can move.
Yeah, this is one of his favorite things. I mean, when it gets near the end of the day, he starts pulling on my pant leg and saying, it's time to warm up the snowmobile. I want to go run. He loves to run on the ice. You should see him in the living room here. He's listening to the snowmobile yell. He was sleeping. All of a sudden, now his ears are perked up.
Oh boy. Are we going?
Yeah, he does about 4 miles like this on the ice.
It's amazing.
About to have to wrap it up, guys.
Yeah.
Tell you what, I'll throw it over to you, Soundly, and you can we'll close out with that video you got ready to go.
Yeah, so we talk a lot about George and the work he's put into it, and I think that this clip to me kind of gives you some context and kind of summarizes the efforts that he's put in, and just wanted to show you guys this.
Didn't want to get my feet wet. I had my tennis shoes on. Right there, the ice augers probably the ice thickness is around 25 inches right there. It's binding.
That was one hole, George. How many did you drill?
Several times too.
A lot more impressive with you pulling it out by yourself.
Yeah. That's it.
Awesome.
Oh, I might want to mention there's another Hangout channel that I've been using to get away from Debbie.
Well, don't say it here.
Rebel.
Don't say it here. She'll hear you. She's watching.
Well, Rebel won't let her on. Rebel has a channel called the Ball Pit on Discord. So if anybody wants to get away from the nonsense and vitriol that seems to follow Debbie, come and visit us on Rebel. I've been hanging out there lately.
Yeah, I've already joined, George.
It's a relief. It's a relief from the nonsense. It's pretty sane and quiet on Rebel's channel. People act adult there.
Yeah, I know exactly what you mean. The other Discord that we are not naming, where Debbie likes to show up, it's amazing how people will just tolerate that for hours on end. It's like,
yeah, you tune in a few days later and it's the same thing going on.
yeah, and people, this is kind of the character of the flat Earth meme anyway. Is that they ask questions, they get direct answers, and then they just forget that they heard that answer an hour later.
Yeah.
And that's
particularly true. Quartus had me visit a site the other day called Alt Earth, and that the lady that runs that is Grayson, I believe, and she's like kind of a quiet Debbie, about every bit as crazy as Debbie, but not as not shouting and not as toxic as Debbie is.
Yeah.
But still has the same misunderstandings and worldview that's just totally bonkers. And her mods are really crazy. There's one mod on there by the name of what do you call himself? Judas. I mean, the guy was just a train wreck. He was a jerk and an ass, and besides that, not very bright. So.
All right. I think we ought to say goodnight. We've been going at it for about 2 hours, 20 minutes. So great stuff, though. Really awesome stuff you showed us tonight, George.
Well, hopefully now in about over the next week, I'll be editing all the videos and get footage together and start posting more updates, and then getting ready for the final summary of everything.
Sounds
over
good.
The past few months, but the summary, analyzing the data, and that probably won't be out for another couple weeks or so, because I have to get data from you, and we have to coordinate.
Yep.
Share data and crunch through all the numbers.
Sounds good. Looking forward to it, George.
Alrighty, Jesse.
All right. Have a good night. Have a good night, Stanley. Thanks.
Oh, Stanley.
Yes.
I found your hat out on the ice. And I also got the whatever you call it, the screw straightened out for you for the telescope.
Oh, you got that straightened out? Wow.
Yeah.
Impressive.
It's not perfect. It's got a little bit of a waver to it, but I think it'll be totally functional.
Awesome. Thanks, George.
And was there anything else? I'm trying to remember. Was there something else I was supposed to do for you?
Well, we had talked about maybe creating like.
Oh yes, for the P900. Yeah, we need to talk about that.
Yeah, I think
because I had a question regarding the lens when it is extended, as far as making that support. We need to talk about that because there's about a 32nd of an inch there that I need to either take into account or not, and I need your input on that.
Okay, yeah. Just for context, I had spoken. George is basically can machine pretty much a bunch of the different things, and he has machined different things that we actually used while we were there. But me and George had talked about machining a cradle for the P900 so that you could securely mount it to a platform and prevent it from having any type of shake or droop, even in wind. So that's what we're talking about doing. And George was taking up the challenge.
Well, it's not much of a challenge. I think it'll be pretty straightforward and easy to do.
Right.
Because what I'm thinking of doing, what will probably work out just right is the housing on your lens is 2.5 inches in diameter, and that would be just about right on a piece of 2.5 inch PVC pipe cut in half, and it'll be slick and with very low friction, so your lens can move in and out along that half pipe, so to speak.
Yeah.
I'm going to try that first. I think that'll be the slickest way of setting something up for you.
Right.
All right, I'm going to hit the stop broadcast.
Well, let me answer C Rizzy real quick.
Go for it. Yeah.
Yeah, C Rizzy, there is a normal camera thread on the bottom, but the problem with the P900 is that whenever the lens is fully extended, you get lens droop, and second, when you're at full magnification, any little, I mean, you could lock it down to a tripod as hard as you wanted to. Any little breeze in the end of that lens makes the whole frame shake. So yeah, I mean, the P900 needs something else. You need
more support.
Yeah, more support out on the end of the lens. Where the actual lens is. Where the actual light's coming in. You just don't want that to move at all. And unfortunately, I haven't found a good way. Even with there's those like telephoto lens brackets. I forgot what they're called now, but you can buy brackets for telephoto lenses to support those. Well, you need something like that for the P900, and there's no good way to do it because it's a point and shoot, and the lens zooms in and out, so it has to go back inside of its housing. So that's what we're talking about. We're talking about making a cradle for it. Okay.
All right.
One thing in final, I really enjoyed having you two up here. I'm glad you came, and Con and I both enjoyed you immensely, and welcome back. Come back anytime. In fact, what people might be aware of is the ice conditions are not deteriorating yet here. So if anybody wants to see the setup, they're welcome to come up. I'm probably going to be able to keep things set up for another 2 weeks before I have to start really tearing things down for the season. Once now that you understand some of the tests that are going on, if there's a particular test you'd like to see done, pass it along to Soundly, Jesse, or myself, and I'll try to incorporate it.
Absolutely. And George, thanks for having us come up. We had a great time, and yeah, for sure.
All right. Night, guys.
All right, guys.
All right. Good night.
Bye.
Bye.